Hi students, in this video we are going to discuss the questions that were part of the numbers quiz. Now before you go ahead and watch this video, make sure that you have attempted the quiz and that you have tried to solve every question in the quiz. Alright, now let's proceed. We go to the first question. The first question says the sum of the first n consecutive even integers is given by, and you need to choose which of these is right. Now I want to discuss two methods to solve this. The first method is using substitution in the options. Say you take n is equal to 2, right? In that case, the first two consecutive even integers are 2 and 4. Now 2 plus 4 is equal to 6. Now check in which option you do not get 6 so that you can eliminate those options. Let's try to substitute it in option A. If you put n is equal to 2, you get 2 into 3, right? That's equal to 6. So that's correct. So let's hold option A and move to option B. In option B, if you substitute n is equal to 2, you get 3 over here, right? Therefore, we can eliminate option B. Similarly, in option C, you get 2. Therefore, we can eliminate option C. And in option D, when you substitute n is equal to 2, you get the answer as 1. Therefore, you can eliminate option D as well. And you are left only with option A. The same thing is true with option E also, right? If you substitute n is equal to 2, you will get 4. So option E also can be eliminated. And you are left with option A, and therefore the correct answer is option A. Now what about the second method? Over here, let's see how we can solve it. Let's take for an example the first three consecutive even integers. That's 2, 4 and 6. Now 2 plus 4 plus 6, if you write it like this, you can see that 2 is a common factor of these three terms. So let's take out 2 and this becomes 2 into 1 plus 2 plus 3. Now we know that 1 plus 2 up to n, this over here is equal to n into n plus 1 by 2, right? This we have discussed in the previous videos. So let's substitute that over here and you get 2 into n plus 1 by 2, right? If you have n terms, and that's also equal to n into n plus 1. And hence the answer to this question is option A. Let's move to the next question. Alright, so 5 into 82.8 plus 0.7 minus 3 into 82.8. So this is a fairly straightforward question. You just need to solve it. Over here you have 5 into 82.8. Alright, and over here you have 3 into 82.8. So it's all about solving it in the best manner. So let's club it over here. So this becomes 5 minus 3 into 82.8 plus 5 into 0.7. That's over here. Now this is 2 into 82.8 and that becomes 165.6, and you add 3.5 to that and you get your answer as 169.10, and that is option B over here. Let's read the question. Bob says he has a set of numbers in his mind. He also says that if x is a number that he has decided to include in his set, then x minus 3 is also part of his set. Finally, he says that as he loves the number 0, it's definitely included. Which statements are definitely true? Alright, now let's see the answer options. Over here, the first statement is 3 and 6 are part of Bob's set of numbers. Minus 3 and minus 6 are part of Bob's set of numbers. And minus 3.5 and minus 6.5 are part of Bob's numbers. Alright. Over here, it's given that 0 is definitely included, right? So therefore, x minus 3 also has to be included. Therefore, 0 minus 3, that's minus 3, also has to be included, right? Now, if x is equal to minus 3, then x minus 3 would be minus 6. Therefore, minus 6 also has to be included. And hence, the numbers that should definitely be part of his set of numbers are 0, minus 3, minus 6, minus 9, etc. And that comes to answer option B over here, because only minus 3 and minus 6 are definitely included in this set. And that's answer option B over here. Alright, now let's go to the next question. Find the sum of the digits of 10 to the power 54 minus 54. Alright, now when you expand 10 to the power 54 and you subtract 54 from it, what's the number that you will get? You will get a number that's going like this, 999, quite a number of times, and then it will end with 46, right? Why is that so? Let's quickly see. What would have this been if it's just 10 to the power 3 minus 54? that would be 1000 minus 54, right? And you will get 946, right? Therefore, when you have 10 to the power 3, you have only 9. Similarly, if you have 10 to the power 54, you will have 52 nines, and then it will end with 4 and 6. So you just need to add these up to get the sum of the digits, and that would be 468 plus 10, right? And that gives you the answer as 478, which is option B over here. All right, now let's move to the next question. The next question reads, 496 is a perfect number. A perfect number has the peculiar property that the sum of all the factors of the number is equal to twice the number. Now we need to find the sum of the reciprocals of the factors of 496. Alright, now what's the answer to this question? The correct answer is option A, that's 2 over here. Now to understand this, let's take a simpler perfect number first, and then we'll come to 496. Over here we have 6. 6 is also a perfect number. Why is that so? What are the factors of 6? It's 1, 2, 3 and 6. And if you add these factors, you'll see that you get 12, which is equal to 2 into 6. Alright, now let's take the sum of the reciprocals of the factors. That's 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 6. Now this is equal to 6 by 6 plus 3 by 6 plus 2 by 6 plus 1 by 6. And that's equal to 6 plus 3 plus 2 plus 1 by 6, right? And over here you can see that you've got every factor, and we know that the sum of the factors is equal to 2 times 6, right? So 2 times 6 by 6 gives you 2 as the answer. The same is true for any perfect number. Over here we have 496, and if you factorize 496, you'll get 2 to the power 4 into 31, right? And with this you can write all the factors. So the factors of 496 are 1, 2, 4, etc., right? The next one would be 8, and it will go on like that. All right, and it will go till 496. Now if you take the reciprocals, that's 1 by 1 plus 1 by 2 plus 1 by 4, etc., up to 1 by 496. Now this over here will give you an expression similar to what we've seen over here. You will get 496 in the denominator, and in the numerator you will get the sum of every factor of 496. And because 496 is a perfect number, and that's mentioned in the question, right? Therefore, when you add all these factors, you will get 2 into 496. Now, therefore, the answer is 2 into 496 by 496, which is equal to 2. And that's why the correct answer to this question is option A. Let's read the next question. X is an odd number such that f of x is equal to the product of all even numbers till x. For example, if x is equal to 9, then f of 9 is 2 into 4 into 6 into 8. Right, because 8 is the highest even number that's less than 9. Alright, now find the greatest prime factor of f of 31. Alright, what's the answer to this question? The correct answer is option C, that's 13. Now why is that so? F of 31 is 2 into 4 into 6 up to 30, right? Now over here you have 15 terms, right? This is 2 into 1, and this over here is 2 into 15, right? So you can just count using these terms. So this is 2 into 2, this is 2 into 3, etc., right? So 1, 2, 3 up to 15. So we have 15 terms, and in each of these terms 2 is a factor. Let's take that out. So you get 2 raised to 15 into 1 into 2 into 3 up to 15, right? Now we need to find the greatest prime factor of f of 31. Now over here you have the numbers till 15. So which is the highest prime number that you have over here? That's the prime number which is less than 15, and you can see that the greatest prime number that's less than 15 is 13, right? Therefore, the correct answer to this question is option C, that's 13. Let's read the next question. X is equal to 1 by 171 plus 1 by 172, etc., up to 1 by 180. Now we need to find the value of 1 by x is in between what? Alright. What's the answer to this question? The correct answer is option A. That is 1 by x is between 17 and 18. Now let's see why that is so. Over here we have given that x is equal to 1 by 71 plus 1 by 72, etc., up to 1 by 180, right? So over here you have 10 terms. You can just count over here. You have 1 over here, 2 over here, 3 over here, and it goes till 9, and then you have the 10th number. So there are 10 terms over here. Now instead of each term, let me replace that with 1 by 170. So you can see that 1 by 170 is greater than 1 by 171, right? Because the denominator is lesser, so you get a higher value. Similarly, 1 by 170 is greater than 1 by 172. So for each of these 10 terms, I replace it with a higher value, which is 1 by 170. Now, when you add these up, you will get 10 by 170, and therefore, because each value is greater than these values, therefore x will be less than 10 by 170, right? Now, in a similar manner, you can see that x will be greater than 10 by 180. How do you do that? Instead of each of these terms, if you substitute 1 by 180, you will see that x is greater than what you get by adding those two together, right? Those 10 terms. So x will be greater than 10 by 180. Now, therefore, we get that 1 by 17 is greater than x, and that is greater than 1 by 18. Now, let's take a quick side note. We know that 2 is less than 3 and 3 is less than 4. Now, let's take the reciprocals of each of these terms. We'll get 1 by 2, 1 by 3 and 1 by 4. Now, over here you can observe that when you do this, these signs have to be reversed, because 1 by 2 is greater than 1 by 3 and 1 by 3 is greater than 1 by 4. Similarly, over here in this expression, if we take throughout the reciprocals, over here we get 17, over here we get 1 by x, and over here we get 18. Now these signs have to be reversed. So 17 less than 1 by x less than 18, and therefore the correct answer is option A. That is 1 by x lies between 17 and 18. Let's read the next question. A is equal to 8 factorial minus 10 square. Find the greatest value of x such that 3 to the power x will perfectly divide A. Alright, what's the correct answer to this question? The correct answer is option A, that's 0. Right? You do not have even 3 to the power 1 which can divide A. Now let's see why that is. Over here we know that A is equal to 8 factorial minus 10 square, right? The first step is we need to factorize 8 factorial. Now how do we do that? What are the prime numbers that are less than 8? They are 2, 3, 5 and 7, right? So we need to see in 8 factorial how many 2's are there, how many 3's are there, how many 5's are there and how many 7's are there. Alright, let's start with 2. We take 8 over here. Now when you divide it with 2, you get 4. 4 by 2 you get 2, and 2 by 2 you get 1, right? So 4 plus 2 plus 1, that's equal to 7. So there are 7 2's in 8 factorial. Similarly, when you do 8 by 3, you get a quotient of 2, and so there are 2 3's in 8 factorial. Now 8, when you divide it with 5, you will get 1. Similarly, 8 by 7 also you will get 1. So there is 1 5 and 1 7 in 8 factorial. Therefore, the prime factorization of 8 factorial is 2 to the power 7 into 3 square into 5 into 7. Now 10 square can be prime factorized as 2 square into 5 square, right? Because 10 is equal to 2 into 5. Therefore 10 square is 2 square into 5 square. Alright, now in this expression, let's take out 2 to the power 2 into 5. And over here we are left with 2 to the power 7 minus 2. That's 2 to the power 5. And 3 to the power 2 itself. And 7 itself. And over here you have 5. So that 5 is taken out, right? Similarly over here you are left with 5. And this part over here simplifies to 2011. Now you can see that there is no factor of 3 over here, right? 2011 is not divisible by 3. How do you do that? Sum of the digits. 2 plus 0 plus 1 plus 1 is equal to 4. Therefore 2011 is not divisible by 3. Similarly over here also you can see that there is no 3 over here, right? Therefore this number over here is not divisible by 3 at all. So there is no power of 3 which will divide this perfectly. Hence you have to do 0, right? Because 3 to the power 0 is equal to 1, and 1 will perfectly divide this number over here. Therefore the correct answer is option A. Let's read the next question. 10 to the power x into 35 to the power x plus 1 into 2 to the power 2x is equal to 2 to the power y into 7 to the power 4 into 5 to the power z. Now we need to find x, y and z. Now what's the correct answer to this question? The correct answer is option C. Let's solve it. Over here we have 10x, 35 to the power x plus 1, 2 to the power 2x, right? Now 10 is 2 into 5. So I can write 10x as 2 to the power x into 5 to the power x. Now 35 is 5 into 7. So I can write this as 5 to the power x plus 1 into 7 to the power x plus 1. And over here I have 2 to the power 2x. Alright. Now over here I have 2 to the power y, 7 to the power 4 and 5 to the power z. Now on comparing the left hand side and the right hand side, you can see that over here you have 7 to the power x plus 1 and that is given as equal to 7 to the power 4. Therefore x plus 1 has to be equal to 4 or x is equal to 3. Alright, now let's see the powers in of 2. Over here you have x and you have 2x. So 2x plus x, that is equal to y, which is over here. So 3x is equal to y. We know x is equal to 3. So 3x is equal to 9. So we have the value of y also. And what about z? If you check the powers of 5, over here you have x and you have x plus 1. That's x plus 1 is equal to z over here. So z is equal to 2x plus 1, x is equal to 3. So 2x plus 1 is equal to 7. So our answer is 397. That's option C. Let's read the next question. Find the sum of the digits of 10 to the power 80 minus 37. Alright, what's the answer to this question? The correct answer is option C, that's 711. Now there are two methods with which you can do this. Now the first method is 10 to the power 80 minus 37 will be a 80 digit number, right? Now if you don't need to by heart this, just simplify it and try it out. If it was 1000 minus 37, right? What would be your answer? Your answer would be 963, right? And this is a 3-digit number. And over here, this 1000 is 10 to the power 3, right? So 1000 minus 37 or 10 to the power 3 minus 37 gives you a 3-digit number. Similarly, you can see that 10 to the power 80 minus 37 will give you an 80-digit number. And the number will look like this. You'll have 999, etc. And it will end with 6 and 3. There will be 78 nines. And then you have 1 6 and 1 3. So if you add all these up, that's 9 into 78 plus 6 plus 3. That's 702 plus 9, which is equal to 711. That is option C. Another method is, remember, digit sum is nothing but the remainder when you divide with 9. So if you were asked to find the digit sum till you get to one digit, over here 7 plus 1 will give you 9, right? So if that was the question, then or even in this case, you can apply this method also. You just need to find the remainder when you divide the given number by 9. Now 10 to the power 80 by 9 gives a remainder 1, right? Because 10 by 9 remainder is equal to 1. So over here you have 1 to the power 80, which is 1 itself. And 37 by 9 also gives you a remainder of 1, right? Because 37 is 36 plus 1. So 1 minus 1 is equal to 0. So that means the digit sum should be either 0 or it should be 9, right? In this case, it should be 9. Alright, now let's see the answer options. You can see that in option A, 7 plus 1 plus 2, that's 10 and 1 plus 0 is 1. So option A is eliminated. What about option B? 7 plus 2 is 9 and 9 plus 5 is 14. And in 14, 1 plus 4 is 5. So that's not equal to 9. So option B is eliminated. What about option C? 7 plus 1 plus 1 is equal to 9. So let's hold it. What about option D? 8 plus 2 is 10 plus 3 is 13. And in 13, 1 plus 3 is 4. So option D is also eliminated. And in option E, 1 plus 1 plus 2, that's equal to 4. So option E is also eliminated. And therefore, the correct answer to this question is option C. Let's read the question. P is a whole number. P cube is divisible by 200. Find the largest positive integer that definitely must divide P. Alright, what's the answer to this question? The correct answer is option D, that's 10. Now let's see why that is. P cube is given as 200x, right? Because it's mentioned that P cube is divisible by 200. So P cube has to be a multiple of 200. Now when you factorize 200, you will get 2 cube into 5 square. Alright, now if you take the cube root of this, P will be equal to 2 into 5 to the power 2 by 3, right? Because over here you have 5 square. So you have to divide the power by 3 to take the cube root. So you get 5 to the power 2 by 3 into some constant, right? X to the power 1 by 3. This can be treated as some constant. Alright. Now over here it's mentioned that P is a whole number. So it cannot remain as 5 to the power 2 by 3, right? So we have to take 5 as 5 itself. Therefore 2 into 5 into a constant is what P is. Now remember, if P is 2 into 5 into a constant, that's 10 into a constant, P cube will be 1000 into a constant. And this is also divisible by 200. So it does not violate the first criteria over here. Therefore, P must be divisible by 10, and hence the correct answer to this question is option D. Let's read the next question. A is equal to 12 factorial minus 4 into 6 factorial to the power 2. Find the greatest value of x such that 3 to the power x will perfectly divide A. Alright, what's the answer to this question? The correct answer is option C, that is 4. That is 3 to the power 4 will perfectly divide A. Alright, let's see why that is. The given number A over here is 12 factorial minus 4 into 6 factorial to the power 2. Alright, now over here and here 6 factorial is common. Let's take that out. So over here we are left with 12 into 11 into 10 into 9 into 8 into 7, right? Because 6 into 5 etc. up to 1 is 6 factorial, which is what you have taken out. Over here we are left with 4 into 6 factorial because we have two 6 factorials and we have just taken out 1. Alright, now over here the next step is you factorize these parts. For example, 12 is written as 2 square into 3. Similarly, 10 is written as 2 into 5, etc. That will help us to take out common terms quicker. And then you take out common terms, so you'll get this expression over here in the outside, and inside the bracket you'll have 11 into 3 into 7 minus 1, and this part over here simplifies to 230. Alright, so this expression, that is A, is equal to 6 factorial into 2 to the power 6 into 3 square into 5 into 230. Now we have to see how many 3's we can take out over here. Now over here directly we can see there are 2 3's. Now in the case of 230, it's not divisible by 3, right? Because 2 plus 3 plus 0 is equal to 5. Therefore 230 is not divisible by 3. And what about 6 factorial? How many 3's are there in 6 factorial? We do that over here. 6 divided by 3 gives you 2, and 2 divided by 3 gives you 0. So 2 plus 0, that's 2. So you have 2 3's in 6 factorial, and hence you have 2 3's over here and you have 2 3's over here. Therefore the correct answer is 2 plus 2, that's equal to 4, or option C. Let's read the next question. Find the number of factors of 13 factorial. Alright, now what's the answer to this question? The number of factors is 1584, or option B. Now to proceed with this, the first step is we need to prime factorize 13 factorial. Now how do we do that? First we list down all the prime numbers till 13. That's 2, 3, 5, 7, 11 and 13. And then we have to check how many of each of these is there in 13 factorial, right? Let's start with 2. How many 2's are there in 13 factorial? 13 by 2 gives you 6. 6 by 2 gives you 3. 3 by 2 gives you 1, right? So 6 plus 3 plus 1, that's 10. So you have 10 2's in 13 factorial. Similarly, if you want to find the number of 3's in 13 factorial, 13 by 3 is equal to 4. 4 by 3 is equal to 1. 4 plus 1 is equal to 5. So there are 5 3's in 13 factorial. Similarly, you can see that there are 2 5's, 1 7, 1 11 and 1 13. Now after you prime factorize, we can easily find the number of factors. We just need to add 1 to the powers and multiply it, right? So 10 plus 1 gives you 11, 5 plus 1 is 6, 2 plus 1 is 3, 1 plus 1 is 2, 1 plus 1 is 2 and 1 plus 1 is 2. Now when you multiply these numbers, you will get the answer as 1584, and that is option B. Let's read the next question. 7 2 by 3 minus 2 1 by 7 divided by 1 by 7 minus 2 by 3. So these are mixed fractions and we need to simplify them to solve this expression. Alright, what's the answer to this question? The correct answer is option C, that is minus 116 by 11. Over here 7 2 by 3 can be simplified as 7 into 3 plus 2 by 3, right? So that's 21 plus 2, which is 23 by 3. Similarly, 2 1 by 7 is equal to 15 by 7. So the expression becomes like this. Now 23 by 3 minus 15 by 7, you can simplify it as 23 into 7 minus 15 into 3 divided by 3 into 7, right? So 3 into 7 is the denominator of the numerator. Similarly, over here also 3 minus 2 into 7 divided by 3 into 7, which is the denominator. So these two parts gets cancelled. So that's why you don't even need to write it over here. The expression becomes 23 into 7 minus 15 into 3 divided by 3 minus 2 into 7. That's equal to 116 divided by minus 11, which is the same as minus 116 by 11, and that is option C. Let's read the question. How many whole number Pythagorean triplets can you form where one of the sides other than the hypotenuse is equal to 24? Alright, what's the answer to this question? The correct answer is option D, that is 8. Now, this is the same question if you were asked in how many ways can you write 24 square as the difference of two squares. Why is that so? If you can do this, that's 24 square is equal to x square minus y square, and you can rearrange the terms and you'll get x square is equal to 24 square plus y square, right? And if this is possible, then x, 24 and y form a Pythagorean triplet, right? Now in this case, you can see x is the hypotenuse and 24 is one of the sides other than the hypotenuse. And that's what is asked in the question. All right. Now 24 square is equal to 2 to the power 6 into 3 square on prime factorization. And to find the number of ways in which you can do this, you just need to find the number of ways in which you can write 24 square as odd into odd or even into even, right? We have already covered this in a previous video. Now, if you're not familiar with this, just watch that video one more time. All right. Now, 24 square is an even number. Therefore, you cannot write it as odd into odd. Therefore, that's 0 over here. Now, let's see in how many ways you can write it as even into even. Now, you have 6 2's, right? Now, to make it into even, all possibilities, we can distribute these 2's into two numbers in these ways. So, this is the first number, this is the second number. So, I can give 1 2 over here and 5 2's over here, or I can give 2 2's over here and 4 2's over here, or I can give 3 2's over here and 3 2's over here. Alright, now let's take one case, one of these cases. In this case, I can distribute the remaining 2 3's either as 0 2, 1 1 or 2 0, right? What does that mean? If I do it in 0 2, what will be the two numbers? So I'm giving 0 3's to this part. So the number is 2 itself, and I'm giving 2 3's to this part. So this number will become 2 to the power 5 into 3 square. So these are the two numbers. Alright, what about this case? If it's 1 1, then the two numbers are 2 into 3 and 2 to the power 5 into 3, right? And if it is 2 0, what are the numbers? It will be 2 into 3 square, and the part over here will be 2 to the power 5 itself. So these are the three ways for this case. Similarly, you have three ways over here and you have three ways over here. But remember, in this case, the powers are same, 2 cube and 2 cube. Therefore, 0 2 and 2 0 will not produce a different result. The two numbers form will be the same. So you just have two ways over here. Now therefore, the number of ways in which you can write 24 square as even into even is 3 plus 3 plus 2, that's 8 ways. And therefore, the correct answer to this question is option D, that is 8. Let's read the question. In how many ways can you write 720 as the product of two positive integers? What's the answer to this question? The correct answer is option C, that's 15. Right, let's discuss how that is. So you need to write the given number 720 as the product of two positive integers, right? Now the easy way is you just find the number of factors of 720. So for that, you first prime factorize 720. So that's 2 to the power 4 into 3 square into 5. Now the number of factors would be 4 plus 1, that's 5, into 2 plus 1, that's 3, into 1 plus 1, that's 2. So 5 into 3 into 2, you will get 30. So you have 30 factors, right? Now over here, you can see that 1 is a factor and 720 is a factor, but they are occurring together when you write them as the product of two positive integers, right? Therefore, the correct answer is 30 divided by 2, which is equal to 15. And over here, you can see these are the 15 ways in which you can write 720 as the product of two positive integers. So quick review, you just need to find the number of factors and divide that with 2. Let's read the question. In how many ways can you write 720 as the product of two integers? So what's different from the previous question? Over here you have two integers. So you have to take positive and negative cases, right? Now again, what's the answer? The answer in this case will not be 15, it will be 30, right? So over here you have 15 ways in which you can write it as positive into positive. Now you will also have 15 ways in which you can write 720 as negative into negative, right? For example, negative 1 into negative 720 also gives you 720, or negative 9 into negative 80 also gives you 720. So 15 plus 15, that's 30, and 30 is your answer. So the process remains the same. You find the number of factors, and number of factors by 2 gives you 15, and then you need to multiply this 15 with 2. So your answer is 30. That's option D. Let's do this question. 24 has many factorizations like 2 into 12, minus 1 into 2 into minus 12, etc. In how many of these factorizations are the factors consecutive integers? Alright, so what's the answer to this question? The answer is option A, that is 3. So what are the factors of 24? How do we do that? You can either factorize, prime factorize and find the factors, or you can write it like this also, because we know factors occur in pairs. So 1 into 24 is 24, 2 into 12 is 24, 3 into 8 is 24, 4 into 6 is 24, 5 into nothing is, you don't have a natural number, right? So 5 into a natural number does not give you 24, and you stop there, right? 6 into 4 would be a repetition of 4 into 6. So you have 1, 2, 3, 4, 6, 8, 12, 24. These are the 8 factors of 24. Alright, so we have listed them down over here. These are positive factors. Now each of these, when you multiply it with minus 1, you will get the negative factors. So these are the negative factors of 24. Alright, now we need to find the cases where the product of consecutive factors equals 24. Over here you can observe that 1 into 2 into 3 into 4 gives you 24, right? Similarly, 2 into 3 into 4 also gives you 24. Now, minus 1 into minus 2 into minus 3 into minus 4 also gives you 24. But you can note that minus 2 into minus 3 into minus 4 is equal to minus 24, right? So that does not count. So there is 1, 2, 3 cases where the product of consecutive factors is equal to 24. And hence, the correct answer is option A, that is 3. Let's read the question. Johnny was adding the pages of a book. He accidentally treated a number xy as yx, where x and y are unique digits that can take a value from 0 to 9. Alright, because of this mistake, the sum turned out greater than the actual value by 63. What value can x take? Alright, what's the answer to this question? The correct answer is option A, that is 7. Over here, Johnny mistook yx as xy, right? And the sum turned out to be greater by 63. Therefore, xy minus yx is equal to 63, where xy is a number, right? It's a number, it's not x into y, it's a number, right? And yx is also a number. So xy, if it's a 2-digit number, you can write it as 10x plus y, right? For example, 23. 23 is equal to 2 into 10 plus 3, right? Similarly, xy can be written as 10x plus y, and yx can be written as 10y plus x. Now when you subtract these, you will get 9 into x minus y, that's equal to 63, or x minus y is equal to 7. Alright, so what are the possibilities? You can have x as 7 and y as 0, or x as 8 and y as 1, or x as 9 and y as 2. And from the options, there's only one among 7, 8 and 9 given in the options. That's option A. So the correct answer is option A, that's 7. Let's read the question. Johnny was adding the pages of a book. He accidentally treated a number xy as yx, where x and y are unique digits that can take a value from 0 to 9. Because of this mistake, the sum turned out lesser than the actual value by 45. What value can x take? It's very similar to the previous question. Now let's solve it. Over here, you can see that xy minus yx will give you minus 45, right? Because the sum was lesser. Alright. So again, you get 9 into x minus y is equal to minus 45, or x minus y is equal to minus 5, or y minus x is equal to 5. Now if y minus x is equal to 5, what are the values that these y and x can take? You can have y is equal to 5 and x is equal to 0, or 6 and 1, 7 and 2, 8 and 3, and 9 and 4. So these are the 5 possibilities. We need to find the value that x can take. So x can take any value from 0 to 4, right? And over here in the options, you only have one number in this range. Therefore, the correct answer is option D, that is 4. Let's read the question. X and y are two integers. If x divided by y and y divided by x gives the same remainder, then what's the correct answer to this question? It's option A, that is x is equal to y. Remember, if it's not mentioned otherwise, remainder always means the smallest positive remainder. Now, it's given that x by y gives a remainder a and y by x gives the same remainder a. Alright, now if x is less than y, then x by y would give a remainder x, right? For example, if x is 2 and y is 3, 2 by 3 remainder is 2 itself, right? Now, in this case, the reverse, that is 3 by 2, cannot have a remainder of 2 itself, right? Because here you're dividing with 2 itself. Now, because the remainder is the smallest positive remainder, a remainder equal to the divisor means a remainder of 0 itself, right? So you're not getting 2 over here. So this is not possible. Similarly, when x is greater than y also, this is not possible. Therefore, x has to be equal to y, and therefore the answer is option A. Let's read the question. X and y are two integers. If x by y and y by x gives the same remainder, and it's given that x into y is greater than 30 and less than 41, we need to find x. What's the correct answer? The correct answer is option A, that is 6. Remember, in this case, because x by y and y by x gives the same remainder, x has to be equal to y. Alright, now x into y is greater than 30 and less than 41. So x into y is the same as x square. So it's a perfect square. And over here, x and y are integers, right? So you cannot have a decimal value. And we know that 30 is less than x square, less than 41. So between 30 and 41, you just have one perfect square, that's 36, right? Therefore, x has to be equal to 6, and hence the correct answer is option A, that is 6.